us having both host and okay, recording is started. Okay, so with host allocated memory, so you can define functions in this way too. Okay, so it is defined with the help of the host keyword and the device keyword. So one counter is used and the counter is incremented. Okay, that's all. It's dynamically allocating memory for this counter variable. So next we are having one kernel function. Okay, so this kernel function call this calling this function. Okay, after printing something. So here what we can do is can use this particular statement CUDA host allocate. Okay, so ampersand of counter and size of int comma 0. It starts from 0. So counter value equal to 0. So then it is printing the value. After that, it is kernel is launched using the counter value. Then fun is called. So here both the host and device functions are friends with the host allocated memory. Okay, with the help of host allocated memory. So if you have used some functions with both the keywords, you can allocate memory in this way. Okay, so after that you can print all those things. It is again there. Okay, I think this is that function. Counter, so both the things, and global print counter, print after fun and counter would allocate memory, host allocate memory, and okay. Okay, so the same function is repeatedly using in many times. So before executing that program, we will see some other program. It will provide you some basic idea about how we can use the function. This is the first one. So it is executed, but you don't get any values. And we see whether it is, yeah, so this correct one. Okay, so first function program. So the n value is defined as 10. And here we have used the host device. Okay, so and we have declared one array dynamically. After that, we are assigning values to that particular array. Okay, so from kernel function, we are calling this function fun. So after that, again, we are having one more host device function print for printing the values in that particular array. Okay, so next, again, one more kernel function. Okay, so here you can see the difference from there and here. So in this particular program, we didn't allocate any memory there in the GPU, but we have to add something else to execute that program correctly. So we'll see later. So here in this particular program, we are having so many functions, two host device functions and two kernel functions. Okay. So here in CPU, the array memory is allocated. After that, we are giving values to that array, okay, from 0 to up to n. So n is defined as 10. Okay. So after that, we are copying these values, DARR values from CPU to GPU. Then we are calling the function fun. After that, launching the kernel. So then CUDA device synchronize is used. After that, array is printed. Again, DARR is called. That means the D printers launched there in the GPU. Okay, so we'll see. So the array is having the values. The maximum size of array is 10. Given as 10. Wait. One more time. I didn't change that to GPU. Okay. So that's why what happened is, so previously it is having two array values. Now it is only one array values. I thought of what happened here. So what happened here is just the CPU program is executed and this particular array is executed. That is printed. Okay. So I have to change it to TPU. First program also I didn't change, but anyhow it won't give results. Next we compile. Okay, see here. So you'll be getting the values printed twice. One is from here, so another one is from here. Okay, we're launching this print function. Okay, and so this host device function, and after that, one time it is printed here in this CPU. Okay, so both the times it is printed. So here the functions are clearly called here. So whether it's here, it is not a problem because we have defined this function should be executed from host and the device. Okay, so both the functions. So we'll see the next one. Again, same type of function. So here in this particular kernel, so we are passing the thread IDX for the fun function. Okay, fun is having two arguments. Okay, array is just incremented. Okay, so here it is passed here. And next one is the print. So it is printing the array value. So after that, again one more kernel function. It is passing the array value and the thread values. Okay, see here. So CPU memory is allocated and array is given some value, copy to GPU, and the fun is called. After that, what happens is again um, some values assigned, then it is executed. This one. Both the same program. I have executed twice. Okay. So next we'll see the next one. Okay. See here. So what is the problem with this particular function? Something is a problem. That's why it is not um, printed any value. Okay. So it is the kernel, and we have assigned star x equal to 0, then printing, then going with the main function. Okay, so assigning value x to null, then simply calling the that is launching the kernel. So CUDA device synchronize is called. Given what happens is nothing will be printed here. Anyone guess the error in this particular program? Oh, it is there. Yesterday I would not reach is there. So we'll see. So here we are having some variable. We are not allocating anything, any memory space for that particular variable in CPU or GPU. Okay. So after that, you have to pass the value to the GPU. You have to copy from CPU to GPU. So all those things we have to do. Then only you can able to execute that kernel function there in the GPU. It is having only the kernel function. Okay. So which is the problem, but where program is executing, but logically it is not correct. And the next one, okay. So next one, the same thing, everything is same. And here we are capturing the error. What happens? Why it is not printing anything? Okay, so that error internally happens. So actually, what happens in while writing CUDA program is from this you can easily identify if you haven't assigned or allocated memory space for GPU, and if you are not transferring any or copying any data from CPU to GPU, anyhow the program is executed without any errors. Okay, so already in some previous classes I told, so if something thread allocation or some other allocation, if there is some error is there, okay, the GPU won't tell that is error, that is the error, this is the error, like that. Okay. So, but we don't get the result. Okay, that happens here. See here, there is another one statement we are having CUDA error. Okay, so print what happens there in the error. We are having CUDA get last error. Okay, what is the last error happened there in the GPU? Okay, that will be captured. Okay, and that is printed here. The error name, what is the error statement? Okay, both will be printed with the help of this particular CUDA get error name, CUDA get error string. Okay, so see here, we'll execute. Already it is there. The error number is 700. CUDA error illegal address and illegal memory access was encountered. Okay, because so we are passing something. Okay, some x value is passed, but there is no memory is allocated. Okay, so this x is searching there the memory. Okay, that's why some error occurs. Okay, and next is the so there is one variable p and then printing p. So after that, in main memory, you are allocating memory space. Okay, for x, you are allocating memory space. Okay, simply allocating memory space. That's all. You are not copying data from CPU to GPU. So that part we haven't written here. Only the memory for X is allocated. Okay. So then kernel is launched with 2 blocks, 10 threads. Okay. And Y is assigned as the X value. Again the kernel is launched. Okay. With the Y value. So these things are, we'll see what happens. What is the output of this particular program? You will get some output because the kernel is launched. Okay, so we have some value here and we are printing the value here. So how many times, how many threads are there? 10 threads are there. Okay, how many blocks are there? 2 blocks. 10 into 2, 20 times the 0 will be printed. Okay, I think you could be able to understood this one. Let's see what is the error here. See after that, so an illegal memory access was encountered because we have allocated memory, but we haven't transferred data to that GPU allocated memory location. Okay. So here what I have done is I simply assign x to 10. Okay. So again same thing. It will be printing 10, 10, 10, 10. Okay. So next one. And I think these functions are also there in the PPT. Same thing explaining here. Okay. And the first one is the same program, host and device function and kernel function. From the kernel function, we are calling this. And from main function, allocating space for counter. Counter is assigned to value 0. Then we are printing from main function what is the value of counter. So after that, CUDA device synchronize. Okay. So then function counter will be called. So you can call this particular function from both CPU and GPU. Okay. So it is called here in GPU part of the code and CPU part of the code. Okay. Then trying to print something. Okay. See here. Initially, what will be executed? This will be executed. Okay. The program execution starts from here. This will be executed. That time the counter value is 0. So after that it moves to the kernel is launched. Okay. Kernel is launched. In this kernel you are having the fun counter. Okay. That function is called. So that function what it will do is it will just incrementing the counter. Okay. So then it is printed. Okay. Print k after fun. Okay, the incremental value of 1 is printed. So after that, it returned back here. So again, the fun counter is called. So while calling fun counter, what happens? Again, it will be incremented. So then it is printing. It comes here. So after fun, it will having the value 2. Here also, we didn't allocate any memory location. The CUDA host allocation only done. Okay, so we didn't transfer any data to CPU to GPU. Okay, nothing we have done there. Okay, so in CUDA host allocate, what it will do is, so this CPU will be taken care of transferring the particular data to GPU. Okay, so that will be done with the help of CUDA host allocate. Okay, likewise, it will be printing the values. Okay. So next, we are having sync threads here in the host device part. Okay, we'll see here. So already we have seen the host device functions are friends with CUDA allocated memory. Okay, we'll move to the next one. So here we have written the sync threads. So actually, this particular function sync threads used for synchronizing all the threads. Okay, so I don't. So actually, we have seen what happens while sync thread is using. Okay, so we have seen in the initial classes itself. So if you want to synchronize all the threads, what happens is, so once all the threads is executing, after that only it will go to access some other memory if you have used sync threads. Okay. So while performing dot product, we have been used sync threads because so if some 8 or 10 threads are calculating the pairwise product means all the pairwise products has to be completed. Then only we can go with adding sorry all the pairwise products already calculated. Okay, for that we have used the sync threads. So sync threads will be work on the kernel part. Okay, so it is not available in the GPU. So here we have written the function for both CPU and the GPU. Okay, it is having the host keyword and device keyword. Okay, we'll see what happens. All the remaining things are same. So already I have pasted the code here. So it is executed. Okay, so it throws some error. Calling a device function sync threads from host device function one is not allowed. Okay, so for any host device function, you couldn't call sync thread function. Okay, if it is a kernel function or if it is a device function, you can use the sync threads. Okay, so if any function is executed both in CPU and GPU, you couldn't use sync threads. Okay, so this is the error we are getting. So I'll see the next one. Again, the same counter program, and it is called here. And so instead of CUDA host allocate, so what happens while we using the CUDA MLOC? Okay, so memory is allocated. Okay, so already I told you if you have used CUDA host allocate, so what happens is the CPU taken care of transferring data. Okay, so what CUDA MLOC will do? It will allocate the memory in GPU. Okay, so all the remaining things same. We have already seen. So I have pasted that program here. We'll execute the program. It has returned. So nothing is done there. Okay. So because since we have allocated only memory space there, if you have written the error code, it will show some error. What happens there in that particular? So we'll see. Would allocate. It's again not printing anything. 。 . 。 。 。 . 。 . 。 . 。 . 。 . 。 . 。 . 。 . 。 . 。 . 。 . 。 . . 。 . 。 . 。 。 . 。 。 . 。 。 . 。
Again not printing anything.
See, let us see. I'm going to paste goal set. Let us see if anything will be printed. It's not printing anything. Okay, so due to some error, it's not printing. So we have to, I think so, use some other. That we should allocate. Okay, so it shows the result of the previous code. The same thing. They have printed this one, that also printed there. Okay. So next one is main problem here is um, the CPU can't be access the counter. That is the problem. Instead of CUDA host allocate, if you have CUDA MLR and you are not transferring any value to the GPU that time, so it won't be accessed from the GPU. So in the next one, so what happens while using the global variables? Okay, so global variables already you know that when the counter is defined globally, then all the remaining things are same. Okay, so in CPU there is one variable and there is no other variable is allocated for GPU and the data is not transferred to GPU. We'll see. Surely it will show some error message. You know that. I have executed. So see here, post variable counter cannot be directly read written. Okay. So it is not defined in device. Okay, counter is not defined in device. That's correct only. We didn't define counter there in the, we didn't allocate memory space for the counter in GPU and the value is not transferred. So anything is done. So it automatically throws some error. Okay, that's all. Okay, so what happens here? If you have globally declared that time, all the error came. So if it is not globally declared, you won't get any error. So it's simply executing and not printing anything. Okay. So next we'll see again on global variable. So here we can see what happens. So this particular variable is defined as host and device. So I have pasted the code. See here, you couldn't apply host here. Okay. So either you can declare using some device too, but using host we couldn't declare this variable. Okay, that is the problem. That's why you got so many errors. The error is there in this particular statement. Okay, so next. The host is removed, only device is used. See what happened. Okay, simply the counter is increment. Nothing is passed here. And this one is host device. And this is a kernel program. In the kernel program, you can call function. Okay, it's printing something. The main program you are calling the kernel and CUDA device synchronize. Whether it will work or not, you are not allocating memory space, you are not transferring the data. Okay, see here. Device value counter cannot be directly read in host function. Okay, you couldn't read that function there in the host function. Okay, so because this is mainly allocated for device. Okay, so that variable you couldn't read from this particular host device function. Okay, that is the problem. So we'll see the next one. So we have defined value to n, and we are having the host device function. So there is one for loop is used and array is assigned with some value. So you can call this fun here in kernel 2, and here we are having uh, two variables. One is for GPU and another one is for CPU. The first one is for CPU, the next one is for GPU. So for GPU variable, we are allocating memory space. The array size is n, so the size we needed is n into size of int. And after that, we are having one for loop for assigning values to array. And the next is CUDA memcopy. Okay, here, no problem. Next, you can call this function from CPU2. Okay. It won't give some result. Why? What happens with this code? We didn't get any result. Any idea? Any idea about this error? No? We'll see the next one. From there, we can find out what happens there in this particular program. Here, the same thing. So next, what happens is here we are having the array in pointer array. Then we have used threads here and array memory allocate, and but the data is not transferred. That is, the data is transferred from CPU to GPU, and the kernel is launched. Everything is done. Here, what happens? GPU to CPU is not transferred. Okay. Here also no result. No one Found the answer for that? Okay. We'll see here. Same thing. Same array. And some thread is added. See here. And memory is allocated. Value is given. Name copy. Host to device. So here in this program and all, launching 1 comma n d array and CUDA device synchronize. After that, one for loop is given, the data is printed. It will give some value. Okay. So it is having 111. That value is printed here. Fun array comma n. This array comma n. And after that, the kernel is launched here. Device synchronize. Next, I equal to 0 to n and array of I. See here, that array of I, you are having value from 0 to 10. Okay. And array is incremented. And here, why it is printing 111? Here also one block n threads. Here also one block n thread. Find out. Copy. Copy it from here. This synchronize. Then copy. Here, enter. Okay. Plus 3 days. Okay. So here in this program, whatever changes you have done here, so we didn't use thread here. Okay. So thread only allocating additionally. So even though the fun is called array and it will be having some array values, it is fast, just fast. You are not printing anything. And memory is allocated and value is changed. Then fun array is called, fun of array is called. Okay. Then values are assigned. After that 1 comma 1 already there. I have changed it to 1 comma 1, 1 comma n. And here what do you see? The D array is passed here. Okay, that is the GPU variable. and defun of, okay, this function is called, this function called this function, and it goes there, it will be executed. So after that, okay, fine. So if you are printing the array of values, it will be printing because we are not moving the value from GPU to CPU. Okay, so that is a problem. So if you want to give slash t, likewise your C program, it is printing. Okay. So here in this program, it is using the thread. Okay. So here array thread idx comma 1 because here you are having two variables. Okay. So two variables have been given, values have been given here. After that, okay, the one is point. Okay, why one? Have you anyone? No one is responding. See here. So the one is given here for nn for I less than n. After that, it will be incremental. So we'll give some 5 here. What happens, we'll see. It's not changing. And 5 plus I plus array of I 0. Here the array value is printed. Okay. So the main reason is here this value comes for the blocks. I'll change the number of blocks to 5. We'll see what happened. So based on the number of blocks, see here, this is the problem, I think so. If you are increasing blocks, it will be printing more number of ones because that is number of threads means blocks into threads. So it is increasing less than n is 10. Okay. So next one is write a CUDA code to increment all elements in an array from the course as well as the device. Okay, so here it is incrementing, and so that only we have seen from there. And memory copy goes to device. This function is called from here, then given to GPU, then it is printed. Okay. So after that, another version is written in this way, and you have to find out what happens in that particular code. Increment all the elements in an array. So here we have written this is incrementing. Here we have array is printed. Array right? It's properly correctly incrementing. This one. So if you have allocated in this way, if you have defined in this way properly moving, so if whether dynamically allocating, it's not properly working. And again here what happens is That's not a problem. Only one teacher n can print here. One, oh, two. Okay. So here it is incremented, and again it is properly incremented. So here we are printing this, and so here we are assigning the value, then passing this. The fund ARR n is called. Okay, n value is 10. So this function is called from CPU. The values are printed. Okay. So after this, the kernel is launched. Okay. So using the GPU variable DARR, then CUDA device synchronize. So after that, we are printing the value of ARR. Okay. So now we are getting the result. Okay. So from this today's class, what we could um, so already we have executed all those things. Okay. So what we could understood is while writing code using the host and device function, we must careful enough to define what you have to write inside that function. So how we can call those functions. So if you have used both host and device, you can call that function from kernel and also there in the CPU part. Okay. So if you have used the host keyword, you shouldn't declare any variable. Okay, you couldn't declare it. It is which is not allowed here. So from device, you can declare variable, but that variable will be used from the kernel itself. You couldn't use from GPU part. Okay, sorry, CPU part. Okay, if you have declared any variable using device keyword, that that variable should be used within the GPU part of the program, not from the CPU part. Okay. So these are all things you have to remember while writing code. And so also there is another one library which is available in CUDA is called Thrust. Okay. So it is similar to STL, and so it supports all type of vectors and associated transform. And okay, so programmer has to have an idea of which part of our code is executed there in the CPU, which part of the code is executed there in the GPU. Okay, then only we can easily correlate CPU part and GPU part. So whether you can use host or device, whatever may be that. Okay, so okay, so I couldn't see that message to pasting the program in chat. Okay, all the programs in the today's class I will upload in today itself. Okay, so you go through that program and execute. Okay. So if you have any doubt, you ask me in the next class. Okay, thank you. So that's all about today's class. We'll see you tomorrow. Okay, thank you.